Okay, well here's our augmented matrix again, representing the first, second, and third equations. Now you should understand very well that if we would happen to switch the first and the third equations, the equations would still be the same, they'd just be in a different order, and that wouldn't affect their solution. So if we were to switch the first and the third equations, what would our matrix, our augmented matrix, be? You can do that. Okay, you should do that before you look, and now you should have done that. But here's what you get. We just have the 1, 1, 1, 1 is our first equation now instead of our third, and our first equation goes down to the third, so we get the 2, 3, negative 4, 1 in the third row. Okay, second row stays the same. So we switched the first and the third equations. We can always switch to lines of our augmented matrix at any stage of reduction, and we still get a system with an unchanged solution. The solution to the system will still be exactly the same anytime we switch two rows. So we're free to switch two rows anytime we wish. Now, the goal here is going to be, as we stated, to get this matrix here, ultimately this matrix here, but we make this change. We want to get 1, 0, 0 asterisk, meaning x equals this, and this meaning y equals this, and this meaning 1z equals this. And by switching these two rows, we've made progress. Can you see what the progress is? Stop and think about it for a minute. How are we closer in this form to this goal than we were in this form? And the answer to that is that we've got a 1 here. Okay, just like we have, we've got a 1 here to match the 1 here. So we've made progress in reducing this matrix. Now, before we go on, I want you to do something we're probably not going to actually do, but what is 2 times the second row minus 3 times the third row? And when I say this, I mean 2 times the second row of this matrix now, where we have this matrix, which is equivalent to this one. So we're talking about 2 times the second row minus 3 times the third row. You should calculate that. You should write that down and see what you get. And having done that, now here it is. 2 times the second row is, well, just 2 times this row. You can check it out yourself. We multiply all these numbers by 2. We get 6, negative 4, 8, 6. And negative 4 is getting a little dim there. And negative 3 times the third row. What's that? If you haven't done that already, take negative 3 times this row and see if you don't get what we get here. And now that is negative 6, negative 9, 12, negative 3. Now if we add those, we get 2 times the second minus 3 times the third. That's going to give us, check it out yourself, 0, negative 13, 20, negative 9. So that's an example of a calculation where you add a multiple of one row to another. Now we're not going to use this calculation, although we'll get to the point where we should. But what we do want to do is we now want to go ahead and reduce this matrix. Try to achieve this form. And the first thing I want to do is I want you to figure out what you could do, what multiple of what row added to what multiple of what other row is going to give you a 0 here. So we've got a 3 here. We want to get a 0 here. How could we add a multiple of some other row to some multiple of this row to get a 0? You should think about that. I'm going to tell you, but you should have by now thought that through. So what we want in progress toward this goal, we've got our 1 here. We want to get a 0 here. Now, since we've got a 1 here already, we don't want to change this first row at this point. We are eventually going to want to get our zeros here and here, but right now we're working on getting a 0 at the beginning of the second row, and we do that by, well, you see, if we were to subtract 3 times the first row from the second row, we'd have add negative 3 times the first row to the second. We would get 0 when we added them. So what we want is we want the second row to become negative 3 times the first plus the second. Okay, now we want to do that calculation. We can do that calculation off to the side. Eventually you get to where you can do the calculation in your head, but it doesn't hurt to write it out. So we have negative 3 times the first is going to be negative 3, negative 3, negative 3, negative 3. And the second is 3, negative 2, 4, negative 3. When we add these, we get 0, negative 5, 1, negative 6. Okay, so here, if we replace the second row by what we get when we do negative 3 times the first plus the second, which just corresponds to taking negative 3 times our first equation times plus the second equation, certainly a valid operation, we're going to get negative 5, 1, negative 6. And of course, our third row hasn't yet been operated on, but we might as well go ahead and do that too. Okay, our third row is 2, 3, negative 4, 1. What multiple of the first row or second row would we add to the third row in order to get a 0 here? Okay, we want a 0 here. So you should do that. Okay, now I'm going to do it for you, and I'm not going to write it all out. It takes too long. These videos need to be fairly concise so that you will actually watch them and so that you can rewind them and find what you want. So we're going to do negative 2 times the first row added to the third row. So it's negative 2 times the first plus the third. Now, we're going to have negative 2's all the way across here, so that makes it fairly easy. We're going to have negative 2 to add to this 2, giving us 0. The negative 2 here added to this is going to be negative 2 plus 3. That gives us 1. Negative 2 here added to the negative 4 is going to give us negative 6. And over here, we're going to have a negative 2 to add to the 1. We're going to get negative 1. Now, you see that we've made significant progress toward this form. We've got a 1 followed by zeros here. And if you think about it, you'll see that putting the 1 up here, getting a 1 here by one means or another, allows us to wipe out the 3 and the 2. Okay, it allows us to just wipe out whatever the coefficients are below us and get that first column into the 1, 0, 0 form. Okay, so I'm going to pause for a second just to double check and make sure I've got this right, make sure you've got it right, and then I'll be right back and we'll proceed a little further. Okay, now recall what this means. It means x plus y plus z equals 1, negative 5y plus z equals negative 6, and y minus 6z equals negative 1. Those aren't equations that we got when we did the original analysis, because we started the original analysis off by eliminating z from every equation. Here we've, from 2 of the equations. Here we've eliminated x from 2 of the equations. This gives us 2 equations in 2 unknowns that we could solve for y and z, and then we could back substitute into the first equation to get x. We're not going to do that. We're going to continue to reduce this to this form. So what's the next thing we would want to do? Well, we need to get a 0 here and here. Okay, I'm going to say that, well, let's go ahead and see if we can get a 0 here. Okay, how would we get a 0 here where the 1 is, and what's that going to do to the rest of the row? See if you can see a fairly obvious operation that'll give you a 0 here. Okay, you should have paused, and actually I'm going to pause for a second and write it out off camera. Okay, well, if I add a negative of the third row to the first, I'm going to get a 0 here. So that's how I'm going to do it. I'm going to do negative 1 times the third row plus the first. Now, third row has a 0 here, so negative 1 times that's still 0. Adding it to the 1 here, we still have 1. Adding negative 1 times 1 to 1, well, that gives us 0, which was the reason we did this. And then adding negative 1 times the third to the first. Negative 1 times this is plus 6. Adding it to 1, we get 7. And then finally, negative 1 times 1 is 1. Adding it to 1, we get 2. So the first row becomes 1, 0, 7, 2. Now, the second row, we want to get a 1 here. Okay? And we've got a 5. Now, there are a couple of things we could do. We could switch the second and third rows so we'd have a 1 here. And then we could use that to get rid of the 1 below here. But the calculation's usually a little more messy than that, so I'm going to embrace a little bit of messiness here. Okay, I'm going to say that we're just going to divide this equation by negative 5. We can always divide every coefficient in an equation by any constant other than 0. So we're going to do the second divided by negative 5. Okay, now 0 divided by negative 5 is still 0. Negative 5 divided by negative 5 is 1. So we're going to have our 1 here. Now, unfortunately, we're going to have some fractions, but we can't avoid them. Okay, we're going to get 1 divided by negative 5 is negative 1/5. And negative 6 divided by 5 is negative 6/5. Okay? Now, our third equation is 0, 1, negative 6, negative 1. We've now got a second equation that has a 1 here. So if we were to subtract this second equation, the new second line from the third, the new second row from the third, we get the 0 where we want it. The new second, and we'll say negative the new second plus the third. So see what you get. Anticipate me. See if you get the same thing I'm going to get. You should have done that. You should have written that out. Okay. So what we're going to get is we're going to have this added to this is going to give us 0 and 0. Negative 1 times this is going to give us a 0 and 0. And negative 1 times this is going to give us a positive 1/5 here, which is going to be added to the negative 6 here. So, you might have to do that arithmetic, but a 1/5 added to a negative 6. Negative 6 is negative 35ths. Okay? And when we add 1/5 to that, we're going to get negative 29/5. Okay? Now that should be kind of familiar to you. Remember the 29 that we got in the previous solution, okay? And then we want to do negative this added to this, okay? So negative of this is plus 6/5. Negative 6 is negative 30/5. Negative 30 plus 5 is 24/5. We're going to get something that isn't consistent with what we got before, and maybe we're going to get to the root of the error that we made previously, because there obviously was one. That was an error that I made previously. Okay, so what we're going to have here, I believe, is again negative 24/5. Okay. Now I'm going to go off camera and just detail again that addition here so you're clear about it, because they're fractions. You might not have seen it from my hand pointing. Of course, you should have worked it out yourself, but let's double check it.